Now we're going to do the last part of how to factorize and solve by completing the square. But listen to me, guys. If I didn't mention factorize and solve by completing the square, you can sure use the S and P. So the equations that you're going to do now for the completing the square, sometimes it works with S and P. So if I didn't mention factorize and solve, for example, using the method of completing the square, you can use the S and P. But sometimes I will mention complete the square to factorize and solve, so you need to use this method. What does it mean completing the square? So let's see what does mean completing the square. So first, when I say completing the square, so sure it has a relation or a link with the identities. Now I'm talking about square. So let's a little bit review what does mean a perfect square triangle. So if I look at the first one, x squared plus 8x plus 16, I have three terms. And I can see easily that x squared and 16 are both perfect square. So it's a squared and this is b squared and this is the 2ab. So I can factorize it by x plus 4 squared. I can also see x squared minus 6x plus 9. It's x minus 3 squared. In this part, you will see the first two. And you will see the beginning of it, but the 16 is not there, the 9 is not there, it's missing. I need to do something to let it appear, okay? So what we're gonna do? If you notice that if I take the 8 and I divide it by 2, it will be 4 squared gives me 16. If I take the 6 and divide it by 2, it will be 3 squared is 9. So why? Because this is 2ab. Now we know that this is 2ab. So I'm multiplying b by 2 to have this one. So now I'm doing the inverse step. If I'm, listen to me guys. If I want to have this term, what I'm doing, b is 4. I'm doing 4 times 2 to gives me 8. So now I want to do the inverse of it. So I will divide this one by 2, then square it to have this term. So what we're going to do to be able to understand what we are doing, I will start doing this by an example. As I told you, you're going to tell me, Mr. And I can solve it by S and P. Why you are doing this to me? So for example, this one, I'm going to tell me, I can do it by S and P. Look, this is S6. This is P7. So I can do it by S and P. Okay, I have minus 7. 1 times 7 gives me 7, or I have minus 1 times 7 gives me minus 7. If I add them, it's equal to 6. So no, okay. But my question is solved by completing the square. You need to complete the square. How are we gonna do it? First, try to see where is the beginning of my identity and what is missing. So if I want to look here at this one, I can see my beginning is here, x squared plus 6x. 7 is not, minus 7 is not a perfect square. So I can see here that this is a squared plus 2ab, okay? So if I do 6 over 2, 3, it means if here I had 9, okay, so it will work. So what is missing? It's missing the 9. If I had 9 here, if I had instead of minus 7, if I had plus 9, so I can say that it's an identity. So it's x squared plus 6x plus 9. So it's an identity. But I don't have it. What I need to do? So look what I will do. Let's remove this. So I need to add this 9. But if I add 9, also I'm doing something wrong. I'm changing my expression. So I need to add and subtract half of b squared. Yeah, and I take 6 over 2, 3 squared 9. So I need to add and subtract 9. Why? Because when you do 9 plus 9 minus 9, it means as you are adding 0. So if you add 0 for any expression, you are not changing anything. So I still have the same expression. So I need to take b is 6, I half squared. So 6 over 2, 3 squared. So I need to add and subtract 9. Look here, guys. If you add and subtract 9, as you are adding 0, I'm not changing anything. It's still x squared plus x minus 7. But now, I will take those 3 together. X squared plus 6x plus 9 will give me an identity. And I will subtract those 2 together. So I will repeat again. I said we need to add and subtract the same number. Because if you do plus 9 minus 9, it means you didn't do anything. If you do a step forward, then a step backward, you're still in the same place. So why I'm doing plus 9 minus 9? Because I don't want to change my equation. I want to still have x squared plus 6x minus 7. But since I don't have the third term of the perfect square of the identity, I need to add it. But if you did plus 9, you are changing everything. So I do plus 9 minus 9. But now I take what I need. So what do we need? I will take those three together, x squared plus 6 plus 9. This is my identity. It's x plus 3 squared. And I have minus 16. Minus 9 minus 7 minus 16. Now I have it this way. Okay, miss. And then how are we going to do it? If I look at this one, be careful. It's an identity. Yes, miss. You're going to tell me, no, we didn't see something like this. We saw x squared minus 16. I don't care. It's something squared minus something squared. So yes, it's an identity. How? We're going to see. So I will write it again. So I have x plus 3 squared minus 16 is equal to 0. Okay. 16, it's 4 squared. So it means I have x plus 3 squared minus 4 squared. Yes, miss, it's an identity. It's a squared minus b squared. Don't be surprised. Even if it's a parenthesis, all this one will be a squared minus b squared equal to 0. And we know that a squared minus b squared, the identity, I will write it here. It's a minus b, a plus b. And a here will not be just one term. It's an expression, x plus 3. Why not? So I will have here now how do we gonna factorize it? A, so it's x plus 3. So hey, the a plus b, it means plus 4. This is a plus b times a, it's x plus 3, minus 4. So I'm back to my factorized form. It's factorized. So it's x plus, what is 4 plus 3? 7. And 3 minus 4 gives me minus 1. So that's it. And then I solve it. The first one will give me x plus 7 is 0. So x is equal minus 7. Or x minus 1 is equal to 0. It gives me x equal to 1. So those are my roots. Those are my solution for this equation. I will do another one, guys. Don't worry. Let's do another one. I'll do another one. 1 minute. Another example. I need to remove it. Okay. It's stuck شوي because I need to add one page. That's it. I will add one page here. Here. Another one. That's it. Let's do another example. I can do one. I'm gonna tell you that perhaps it's not a perfect. Okay, let's see what will happen. Let's do another one. If I have now x squared plus 9x plus 20 is equal to 0. I look at those first two. This is the beginning. This is a squared plus 2ab. Let's take other than 9. I will try to give you, for example, something easier to divide. Let's say 10. Okay, plus 20. Gonna tell me okay, and then what? 20 is not a square of. So this one gives me, if I divide it, it's 5 squared, and I need to add and subtract 25. Okay, so I will have x squared plus 10x. Okay, I will add and subtract 25. Look what will happen now. Plus 25 minus 25, and I didn't do anything. I'm just adding كأنه 0 plus 20 is equal to 0. Excellent. So if I take those three together now, I can see this is a squared plus 2ab plus b squared. So 25, it's 5 squared. 2 times 5 times x gives me 10x. So the factorized form of this one, it's x plus 5 squared. Okay. Yes. Now I have here minus 25 plus 20. It gives me minus 5 is equal to 0. I know that's what you are thinking now. You are saying, oh, okay, this is a squared. But how 5 can be b squared. It's not a perfect square. Which number squared gives me 5? Yeah, we know it. Which number squared gives me 5? Will help you. What is radical 5 squared? Yes, it's 5. So it means here b is a radical 5. In here I can write it like this. So it's x plus 5 squared minus radical 5 squared. I can see it now. It's a squared minus b squared. So this is a squared minus b squared. So the factorized form is a minus b times a plus b. Okay, a يعني x plus 5 minus radical 5 times x plus 5, this is a, plus radical 5 is equal to 0, and I solve it normally. So this is, did you see it? This is a minus b, and this is a plus b. And then I will solve each one equal to 0. X plus 5 minus radical 5 is equal to 0. Okay. It will be x is equal, I will take it to the other side, minus 5 plus radical 5. This is the first solution. I'll keep it like this. Or the second one, x plus 5 plus radical 5 equal to 0. It gives me x is equal minus 5 minus radical 5. So this is my second root or my second solution or my 0, as we said. And that's it. Those are the solutions. They could be like this. So not all the time if this one I see it 5, I say, oh, it's impossible. No. Minus 5, it means it was radical 5 squared. If it was minus 2, radical 2 squared, or it could be really a perfect square that I can see it. Now, we're going to do more application from the book during our online session. That's it for this video. I'll try to stop, please. Now I'm trying to just remove the mouse. So don't worry, guys, we'll do more application during our session. Sorry, that's it.